Good morning from Tokyo. I'm Angus Herman from Toshiba Digital Solutions Corporations. Thank you all for joining. So today I'd like to give a general introduction along with a hands-on tutorial about GridDB database, as well as some other tools that you can connect to GridDB and integrate together to create an open source backend for the Industrial IoT system. But before I continue, just a little bit about the housekeeping rules I'd like to mention here. If you have any questions, please feel free to write your comments on the chat box. Or if you wish to know more about GridDB, you can later go to griddb.net and you'll find that there are a lot of interesting contents there about GridDB. Now, today's agenda is as follows. I'm going to start off by, reminding ourselves about the state of data in general. And I'll talk about GridDB and how it fits into the Industrial IoT reference architecture. There will be some use cases and benefits of IIoT and big data applications in general, and I'm going to finish off today's webinar with a hands-on tutorial on how to set up GridDB and other open source tools to form the IIoT backend system. Now, there's a very interesting white paper by IDC, sponsored by Seagate, about the state of data and how it will evolve going forward to 2025. Now, some of the take-home point here is that, number one, data is growing at an unbelievably fast rate from around 33 zettabyte of data in 2018. And it will increase by 5 times, as many of around 75 zettabytes of data in 2025, right? Now, secondly, in terms of where the data is stored, we're seeing more and more of this data going into the cloud instead of locally on-premise. And thirdly, more and more of this data gets generated in real time. Now, amongst this growth of data, there seems to be a significant growth in the connected IoT devices area as sensors get cheaper and the network connection coverage as well as speed keeps going up, keeps improving. Especially some of the areas that will have a significant growth here is the healthcare, showing 36% of growth. You also have manufacturing, financial services, as well as the infrastructure and transportation area. And in the next few years, I think we will still see this growth of data, especially in these kind of industrial settings where there are a lot of sensors generating time series data, and needs to keep this time series data for further analysis. Now, Toshiba itself, just a little bit about Toshiba. So Toshiba has been building mission critical systems to our customers in different industries, such as the energy, for example, manufacturing, transportation, logistics, smart community, and so on. You're talking about the calculation of wheeling charges, monitoring and analysis of different sets of your assets. You're talking about integrated management of smart houses, smart building in a smart city, for example. Now, from our experience, we have been seeing a lot of data growth, and that we think that in order to support this growth of data, in terms of the data management, we think that there's a need to create a purpose-built database to handle this massive amount of data. And so, for example, this is just an example. This is an example of an IoT reference architecture that you can build with open source software available in GitHub or wherever you can download it on the net. So this is an example of an IoT backend that can build using those softwares. from left to right. Typically, in a industrial setting, you would have a lot of devices and different types of sensors producing a lot of data. Now, this data then gets transmitted through different communication protocols, whether you'd like to use the standard OPC UA, for example, or the reliable Modbus, or even the much more modern, and lightweight MQTT, or just even a simple HTTP, depending on your preferences. This data can then be ingested to a streaming platform, such as Kafka, for example, to be further analyzed in real time before making the data persistent to an IoT data storage to be further managed properly, or you could also directly from the sensors, without going to the streaming platform, you can also directly batch the data and ingest it to the database itself as well. Now, what's interesting here is that some of the key differences between these so-called transactional data that you would typically find largely in a relational database, for example, is that transactional data and IoT data have its differences, right? Now, in IoT data, typically you would want to look at the trends of the data itself instead of a point in time value, right? And in order to be able to look at the trends of the data, there is also a need to store the data by time to create a historical data. For example, maybe it's from a few minutes ago or hours ago, or even 10 years ago, and typically as this so-called time series data gets accumulated over time, and even sometimes you would want to store even a high resolution of this data. Maybe for every second the sensors will produce a particular payload, for example. Now this data gets really accumulated. This data gets really big, and there needs to be a data store that is able to contain and manage this data, right? Now, once you have accumulated this data, you can then perform maybe big data analysis and get an actual insight, get a useful insights from this data. Now, while doing this, you could also visualize your data in real time. So if you look at the diagram on the right hand side, you would want to visualize your data maybe in real time and perform perhaps an ad hoc analysis on the go of your data every once in a while. Or if you have a data analyst, then he or she would typically wants to perform big data analysis, requiring you to kind of you could go with Hadoop, for example, or different kind of tools that are available in the market as well. And there are a lot of use cases that you can do once you have your data stored in the proper data storage, right? Now, although you can actually use a more generic database, so for example a relational database to do this, but as you know, this kind of database is not really meant in the first place to scale, right? Or give the performance that you need for your applications, right? So in other words, what we need here is a purpose built data store that is able to handle a massive amount of IoT data. And this is where GridDB comes in. So in a word, GridDB is basically a distributed SQL time series database specifically designed to handle IoT and big data workloads. Now, some of the reasons why GridDB is suitable for IoT data is that, number one, it is distributed by nature. so that you can flexibly scale as your data grows, but without having to sacrifice the good, SQL engine, SQL query that you would typically find in a relational database. You can also scale without losing the performance by adding nodes to your cluster, and you can scale to the petabyte level as your data grows. GridDB is also highly available to satisfy the requirement of a mission critical system. And of course, last but not least, we have also features that makes it easy for you to control or manage your growing IoT time series data. Now, by using this purpose-built time series data, you would then be able to preserve your historical data efficiently, perform, for example, different modeling to predict equipment failure. You can create your a digital twin of your physical systems. This also would require a good management of your sensor data. For energy companies or smart buildings, applications or system, for example, you would also be able to monitor and control your data in real time, as well as another use case where you can where you have your assets, maybe moving assets, your trucks or your shipments, for example. You can track your assets, perform look at your data, perform real-time analytics, and perform your decision making on the go in real time to, of course, improve your bottom line, right? Okay, so that's just a little bit about what GridDB was and what it can do. So I will move straight to the demo itself, but before that, I'd like to just talk a little bit about how I'm going to set up the demo. So I'm going to show you how you can easily use GridDB and other open source software to simulate, I guess, the flow of this IoT data. So I'll be using, first of all, an open data from the Cases project. If you just Google that, you can check what kind of project they're doing. So basically, the data that they took consists of smart sensors such as temperature, motion, light sensors, and they did record a lot of this time series data. This data in TSV file can then be sent to Kafka via the console producers, and then on the other end of the Kafka, it will be consumed by GridDB via the Kafka Connect, the JDBs via JDBC. I'll then show you how the data is successfully stored in GridDB from Kafka itself, and then on the application side, I'll show you how you can connect GridDB with Jupyter Notebook so that you can perform ad hoc analysis, as well as connecting GridDB to Grafana to visualize your data via the GridDB Grafana data source connector. Okay, so let's get started. Okay, so we'll spin up everything in Docker. You can actually use Docker Compose to automate running these containers. But today I'd like to show you step by step on how to run these actual containers. Okay, so first of all, what we're gonna do is to download our open file data. So you can go to Google, type in Cases UCI sensor data. At the top, you can click on this one, and then go to data folder, and there's a file called cases-dataset.zip. If you click on that, the file will be about 13 gigabytes. There's some interesting stuff out there in there, so do check it out. So I've downloaded earlier, and then so the next step that we're gonna do is that we're gonna set up everything in Docker. So first, let's set up the network so that the applications can talk to each other. network create GridDB net, and also I'll create a volume for GridDB to attach to, GridDB data. Okay, and then I'm gonna run Docker container run, name GridDB, network is network we just created. We can open up port 2001. This is the port for JDBC. I'm gonna mount that to our volume like so. Targets var lib grid store, and then so GridDB already has an available image from Docker Hub. It's called GridDB net, available at GridDB net GridDB like so. Okay, so if we run that, actually, so it needs, so we, okay, so let's check logs for that one, GridDB. So the grid is still getting ready, so let's wait for that to finish. While we're waiting for that, let's set up another container, Kafka container. So we're gonna run Docker again, IT Kafka network GridDB net. We're gonna set it from scratch actually using CentOS like so. Alright, and then we're gonna need to install Java, so we'll just copy my cheat sheet there like so. So this is going to take some time. While this is taking the time to load, let's move on to the next container, the Jupyter notebook. So again, we'll spin up another container here on another terminal. Name Jupyter notebook, network, same network, GridDB net. So we're going to need to open up port 8888 because we are going to look at our Jupyter notebook on our browser. Again, there is another image available already, SciPy notebook like so. Alright, so that's should be already running. Let's check that the Jupyter notebook is running well in our browsers. Okay, that's good. Now we're gonna go back to our GridDB container. So let's do that. Exact as a sudo file user it and GridDB bin bash. Okay, just gonna click on yes, that. Okay, so the first thing that we need to check in our Docker, in our GridDB setup is the host name. It's very important. So let's type hostname -i. Okay, so this is the hostname that we get. We need to copy that one because we're going to be using it throughout this demonstration. We're going to copy that here. Okay, like so, and then we're going to use that later. Okay, so one of the things that I'd like to explain to you about with GridDB is that GridDB is basically a distributed database. So if you check the configuration, gs cluster.json, you can see a couple of things. The first one is the cluster name. By default, it's going to be default cluster if you download it from Docker. And then there's a replication number. At the moment, we're using not multicast to talk to one another because it's the one node. We're using a fastcast mode. like so. All right, so we are going to install SQL Workbench actually. Now you can actually head to our blogs, and there's a good blog there. There are actually a lot of good contents there. One of the blog is about installing SQL Workbench. So I'm gonna copy this one. Oops. I'm gonna copy that one here, like that. Okay, so we need to also install the necessary program. So while that waits, actually, we're gonna go to Kafka and download Kafka. So I'm using 2.5.0. So I'm gonna download that into our Kafka container. Good, so it's gonna take some time. So we're going to then spin up the last one, the last container, which is the Grafana. So docker run. Actually, we're gonna start from a scratch. So docker run name Grafana network GridDB net. When I expose post port 3000. Okay, I'm gonna use the CentOS to do that. Okay, like so. Dr. Run name. Okay, miss something here. RM IT. One second. Made a mistake. RM IT, like that. Okay, now let's go back to our GridDB container. Okay, so with the GridDB setup, like I said, we're installing the SQL Workbench. We're gonna use this do cd SQL Workbench. Just gonna quickly copy this one so that we don't waste any time, like so. Oops, we need to do this one first actually. Right, now we'll zip it. Oops, again, where are we? Okay, we can just unzip Workbench like that. Let's do this. Make sure that all these shells can be run. Let's run this SQLDB console. All right, so that should go in. And then the next step is that we're gonna need these parameters. So I've copied the address earlier to here, so they should connect. So basically what you need is the name of the drivers, the location of the GridDB store. Hold on a second. I forgot one thing, and we need to copy that. So let's quit this actually. let's quit this actually, and then we'll copy. Let's quit this first, and we'll copy first the Java driver, the JDBC driver, like so. And then we'll copy this to our path user, to our share path Java, like so. Then we can now again connect to the oops. Okay, I'm just gonna do that. Where is it? Okay, this one. Connect. Okay, successful. So next we are going to set up web API in GridDB. So again, let's get into that. IoT GridDB bin bash, like so. There exec means 0. IT. Okay. Oops. Docker exec IT 0 GridDB bin bash. Okay, like so. And then we are going to clone the required connector. So we're gonna go to GridDB, heads to the web API. We're gonna clone this. No, we're not gonna clone that. We're going to copy the binary that's already available. This one. When we get that, like so. Okay, we're gonna uninstall that. Okay, we're gonna go back to this Kafka while the other one is downloading. We're gonna enter this one, like so. We're gonna enter this one as well. GridDB API, like so. All right. And then we're gonna open up that web API. As now, if you follow the instructions there, basically we need to set up the GS web API home. So we log into this one. So it's gonna be this, okay. And you're gonna need to edit the following files, right? And yes, we do need that actually. All right, so let's go to cd-conf and see. Okay, the griddb.webapi.properties. I think that should be the same. We're gonna change the repository because it contains the IP address, like so. So the first thing that we're gonna have to input is this one, the name of the cluster. We're using a fix this method inside of multicast today. Fix this like so. The address is this one. So we're gonna copy and paste it there. Actually, we don't need this one because this is for fixed lists. Okay, we're gonna put it here instead. This one is 2001. Now here we need to put port 10,001. We don't need this one, so we'll delete that. Like so. All right, So once that's done, we'll run the jar. So let's go back, which is in our lib, then GridDB. Okay, if that's correct, then we're just gonna Spring Boot. All right. Now, the next things that we're gonna do is go back to Kafka. We're gonna cd to Kafka. We're gonna start the Zookeeper. So let's go back to Kafka and just follow the tutorials there. Gonna spin up the Zookeeper, and then we're gonna, so Kafka needs a lot of terminals. So we're gonna do that. We're gonna move to Kafka. We're gonna start the Kafka server start. Okay, like so. We're gonna start again another one. ID Kafka bin bash, like so. And then we're gonna create write some topics, some events to the console producers, just to test that the Kafka is running properly. Like so. Okay, we can move that up. We don't need any more. Okay, let's speed up another one here, and this time we'll spin up the consumer Kafka bin bash, like so. Oops. Like so. We go to here. All right. CD Kafka. Like that. So to check that it's working properly, we'll split this as message 1, for example, and then it will appear here. Okay, message 2, it will appear here. Okay, good. So the next thing that we're gonna need to start is the connection between GridDB and Kafka. So that's the we use via Kafka Connect GridDB JDBC sync. So we're gonna start that one, bin bash. Okay. Like so. Then we need to 1 second. First of all, let's copy this file actually to here. So the name of the Docker container is docker cp csh1, and then this one is D34. Right, so if you check this, the data should be there. Good. Now the next thing that we're gonna have to do is so earlier I've posted it to my GitHub repository, so you can just git clone from there. Install git. Git clone. Alright, So I have how many? Okay, a few minutes left. So we'll check the inside of that Docker. Now there are a couple of files that we need. We need to copy this GDBC sync jar. There's two things, GDBC sync jar as well as the actual GridDB store GDBC to Kafka libs. So we're gonna copy that GridDB JDBC sync jar to Kafka libs, I believe. Like so, and then again we're going to copy another one, which is the grid store, like so. Right, and then the next things we're gonna copy is the parameters. So it should be in the configs. So if we log into, if we cd to config, the two things. We need to copy the connect standalone properties as well as the new GridDB sync properties. So let's copy that, overwrite that to Kafka. I believe it's config. And then connect standalone properties like that. We're gonna overwrite that. And then the other one is that we are going to copy GridDB sync properties. Like so here. Okay, so there's no need to change the connect standalone properties, but we need to check our GridDB sync properties. So let's go there. Config, okay, and then GridDB. Now we had saved our IP address earlier. Gonna copy that. We're gonna change it. Change the notification member here, so that we can connect to it, like so. So that should be good to go. All right. So now that everything is already started, next thing is that we're gonna copy some shell scripts. Two things that I'm gonna copy is the casas convert and the ingest, right? So I'm gonna copy docker casas convert here. Another one is the ingest, like so. Okay, so let's check what's in it. So basically it's just a simple gawk that runs through the CSH 101 data. And if you check the ingest, okay, so what I need to do actually here, okay, so I need to copy this name because this name is different to what's in the file. Like so. All right, so everything is done. So next thing that we need to do is to run this ingest, but first we need to make sure that it is executable. So we'll just run. Okay, so two things that we're gonna do prior to that before we ingest this one. The first thing is that we're gonna close this one. Actually, we don't need it anymore. We're gonna open up another two terminals. ID Kafka bin bash, like so. This time we're going to subscribe to our new events, our new topics. like that. So the topics here are going to be cases. Sorry about that. Like so. Okay, now that's running. What we're gonna do, sorry, I'm gonna speed up another terminals because we need that for Kafka. Don't need this one. So Dr. exact ID Kafka pin bash. So what we're gonna do is to ingest this file. So we're gonna run that file. Right, so that file is gonna parse through all of this data that we converted earlier in JSON format into the new cases topics, and then what we're gonna do then is we're gonna start our GridDB sync here, like so. Oops. Like so. Now what's gonna happen is that this file from this topic will be consumed by GridDB, and then it will be written directly to our GridDB data storage, and I will be able to query here in GridDB some of the select all from, I think it was CH101. We're gonna have a look at our sensor map. So let's check the M001 or whatnot. M001, for example. Okay, still loading because there's still a lot of data. It's taking a lot of memory. Okay, we're gonna stop this actually because we have enough data. Okay, now so that this can connect to here and then start ingesting our data to GridDB. Okay, so it's now ingesting files. So now we go here and select, oops, okay, so let's see what we can do here. There is an sensor T. Okay, hold a second. Let's do this instead. I will limit. Okay. All right. So the data is now inside GridDB, like so. So the next thing that we're gonna do is we're gonna go to our Jupyter notebook that we've run earlier. Okay, we're gonna import pandas SPD, and then we're gonna have to pip install JDB API actually. JDB API. That's like so. Actually, let's go into that because we're gonna have to install a few things. Root, what was it? Jupyter notebook bin bash, like so. Okay. Okay. Up install default jar E, like so. We get the GDC driver because we need that. Let's wait until it finishes. Okay. So if we check ls, okay. So we're gonna copy that grid store jar into user share Java. Okay. So that's good to go. So I'm gonna delete that actually. Now we'll import as well GridDB API. So it should work. We're gonna make some connections. So actually let's copy that one first because it's a different IP address. We're gonna make this connection like so, and then if you fetch some data, okay. Now there's another cool features that you can do directly from pandas, and this is actually from the GridDB API. So if we check that one, this is actually a functionality from pandas. We'll be able to actually see the column name as well, right? Okay, so that's good with the Jupyter. So last but not least, we're gonna set our do we have time? Okay, just 5 more minutes. We're gonna set the Grafana. So let's go to Grafana's page and install Grafana. We're gonna follow this. Okay, Grafana like so. We're gonna yum install Grafana like so. Okay, and then we're gonna start the server. Right, so that's gonna take some time. Okay, so while doing that, we're gonna go to our GridDB web data source and check. Okay, all right, the guide there. Okay, it's gonna take some time. Please bear with me a little bit. All right, so it doesn't seem that we have times, but if you do have time, please feel free to check this, and you should be able to connect to Grafana, right? Okay, hold on a second. I think it's gonna work. All right, now we're gonna quickly git clone into this. Yum install git. Like that. Oops, it's taking a while. Git clone into that. All right, so the next thing that we're gonna do is that we're just gonna copy this into Grafana path, right? So I believe it's let's see, user for lib Grafana, and there should be a plugins there. What is Grafana plugins path? Sorry, we don't have enough time, but you can check the GitHub repository, and it's very simple. Over there you can just simply follow the tutorial and you'll be able to connect GridDB to Grafana for data visualization. Okay, so that's all for today. Thank you for joining. Please check out our contents at griddb.net. There are some important and interesting contents there that you can follow along if you need to ask some questions. There's also you can contact at griddb.net, or if you have any further questions that you need answering, you can go to Stack Overflow and there's a tag GridDB. Please use that and we'll be happily answer your questions there. Okay, thank you today. We'll see you again in the next meeting. Happy developing. Goodbye.